And among this also, I have chosen this facing version because here it's easy to impregnate of your electrodynamic inside this membrane.
नहीं है तो एक मिनट रुक जाओ यार.
So this is the overview, or we'll say this experimental procedure, how we can prepare your membrane inside this lab. So whatever be the waste plastic we have, we can simply shred out, and then we'll go for prepare for dope solution here. So for dope solution, we have to select what is the suitable solvent we have in which we can dissolve our plastics. So here we have chosen this orthocresol, and this is the best solvents to make a solution. So the solution is nothing but this is a dope solution, and here then we'll spread this dope solution in your flat machine, and then we'll prepare your this PET membrane here. And then we'll go for characterization to cross-check what is the nature of your membrane. This is a hydrophilic or the hydrophobic type. Next, please. This is the small part of the calculation. What is the membrane we have prepared? So we'll cross-check what is the porosity and what is the flux of that. Next, please. Next, please. Okay, so here actually we have done some SAMs to just cross-check the morphology of your membrane. So here see what we have varying all the possible parameters. So in possible parameters we say what should be this PET concentration. So that means what PET concentration is nothing but whatever the dope solution we have prepared, how much dope solution we will take. Then we'll go for this coagulation bath. So that means what in coagulation bath, whatever the extra chemicals we have, we'll try to remove it. So here actually what we have taken the 50-50% the methanol and ethanol mixture. And then we'll go for the PG. This is a polyethylene glycol. This is nothing but this is additive just to give the strength of our the membrane. Next, please. These are some tests, and here with the help of that we can check what is the optimized parameters on which we can fabricate our membrane for further separation process here. So here actually what we are varying our polymer concentration, then we'll go for changing for additives, then we'll go for your this WIE, this is nothing but this is a solvent ratio. So WE, this is nothing but this is your the water and ethanol ratio here. So one by one, if you see here, initially we are varying this polymer concentration, so 15 to 19, and then we will optimize the 17 and 18 is the good one. So here actually we are fixing the 17.5, the polymer concentration. Then we'll go ahead for the next parameter. This is your PG, polyethylene glycol. This is additive. And here again we'll just optimize the 2 is the good, and all these are percentage volume by volume ratio, and then go for solvent. And so here we'll take this 50% is good for next process. Thank you. And so here I'll just cross check this water flux, how much water is coming out from this prepared membrane. So we'll see in a first when we'll take our polymer concentration is high, then the reflux ratio is high, but here we have to optimize. So we'll check with this each and every parameters how much the reflux is coming from this water here. Next. Okay, this is the important characterization properties. This is your contact angle, and based on that, it is decided your membrane is hydrophilic and hydrophobic. So here actually, if we'll see and say when we are varying the parameter in each and every case, the contact angle is not crossing this 80 degrees centigrade. So here actually we will say the nature of the membrane is hydrophilic in nature. So this is about the decide the membrane nature should be hydrophilic in nature. Next. So here after the preparation of the membrane, we'll go for this mechanical strength, how much mechanical strength we have. So for that we are just testing, and here we'll see the strength of membrane. This is the 6.334 Newton per centimeter square. So this is quite enough for again reuse for this one. These are the possible source from where we can get this contaminated water in which the concentration of the chromium ion is much more. So here, for the testing point of view, whether the membrane is performing well or not, so we are choosing this chromium as a heavy metal ion for this removal. Next, please. So simply here we have prepared the different concentration solution, and then we'll try to pour inside your membrane and just cross check how much percentage removal is going on actually. Next. So this is your this experimental setup here. With the help of that, we are trying to remove this chromium ion. Next, please. This is the transportation mechanism, how the metal line is moving from the bulk of the solutions to the membrane, and then is passed from your receiving phase side here. Yes, next. Next. Here we can use the two types of membrane. One is your membrane supported, and second one is this carrier supported. So here see what we are emphasized to remove our this chromium metal line from this carrier supported mechanism. Next. So here see what I already told you is a contact angle of the different membrane. So in each and every case, what we are find out, the membrane is not crossing this 80 degree. So that means what all the membrane this is come into the category of your hydrophilic in nature. So from here we can see the or we can identify the colors how your membrane is efficient. So here see what we have just crossed this peak because we are calibrating the concentration of chromium ion by the UV spectrophotometer. So we have decided this wavelength. And then we just prepared this is basic phenomena when we are going to test any colored metal from the UV spectrometer. We have to just draw this calibration curve. Next. So here actually, next please. Next. Okay. So here actually I'm just checking the receiving phase concentration effect and this polymer concentration effect. So we'll see when we are just removing the receiving phase concentration, this is nothing but this S2SO4 here we are choosing. So if we can see, if I just remove the, if we will increase the concentration of the receiving phase, so here the percentage removal is going high. Similar to here this polymer concentration, again we'll see this is showing the reverse effect actually. If we'll increase the polymer concentration, so that means what? There is chances of very dense pore actually. If the dense pore will form, so there is a percentage removal is down. So here we'll see when we are going to increase, then the percentage removal is going to down, and at the 15% volume by volume will observe the percentage removal is too high. Next study on this pH, because the pH is also playing this important role in removal. So here we'll see find out that 0.05 m H3SO4. So initially we'll see this pH is going to down with this time, and here the saturation pH is constant. Same here, we'll change this pH of your receiving phase. So we'll see at 1 we having less, and it's 0.25 we have more. Next. So if overall we can see the conclusion, that means what here for this better removal of the chromium ion, the contact angle of this prepared membrane, it should be greater than 60, but it's not above from 90. And the porosity of the membrane, it's come into this range of the 30 to 45, and here we are using this gravimetric methods to check the porosity of the membrane. And overall conclusion, we will see this 80% of the chromiums we are easily to remove, and with this stable phase concentration of the 0.01. And now here only we have more chances to enhance of the membrane while preparation of the membranes. We can use some nanoparticles, so we can say enhance the efficiency of the removal of chromium ion from contaminated water. Next. Thank you everyone. If any question, then please welcome. Yes, ma'am. Yes, anyone more question? Okay, thank you to everyone, and special thanks to HBTU Kanpur as well as the InDACON to give me opportunity to share my knowledge in front of you. Thank you.
Thank you, sir, for your insightful lecture session. To express a heartfelt appreciation, I would like to felicitate our esteemed speaker. May I kindly invite Dr. Ashish Kapoor, sir, to felicitate our speaker with a momentum. Thank you, sirs. Moving forward towards our second plenary lecture session, we are delighted to have Dr. S.P. Chaurasia, sir. To present his biodata, I would like to call Ms. Mishika.
Good morning, everyone. It is with great honor that I introduce our distinguished speaker, Professor Satyendra Prasad Chaurasia, sir, a highly respected academician and researcher in the field of chemical engineering. Professor Chaurasia, sir, currently serves as Professor HAG in the Department of Chemical Engineering at Malviya National Institute of Technology, MNIT Jaipur. His academic journey began at HBTI Kanpur, where he completed his BTech and MTech, followed by a PhD from the prestigious IIT Bombay. With an impressive research portfolio, he has authored 64 journal publications and 88 conference papers, significantly contributing to scientific advancements. His leadership in research is evident through his guidance of 12 PhD scholars and his successful execution of 7 research projects, demonstrating his commitment to innovation and knowledge dissemination. Sir's excellence has been recognized with 15 awards and honors, a testament to his contributions to academia and industry. Beyond research, he has been an active leader in professional organizations, serving as the chairman of Jaipur Regional Center of IICHE for 3 consecutive years and being nominated as convener of the Committee for International Relations by the Indian Institute of Chemical Engineers.
Thank you. Just a minute, wait.
अरे सुनो एक बार सर को रोकना अभी गए ना सर को रोको उनका फोन देना है
Hello. Okay. Good morning, everyone.
Good morning, sir.
You know, I diluted my PPT, brought down to, mainly UG students, most of the things. But attendance is, I wish it should have been better. Anyway, please move to next. You see, my today's talk is, is for UG membrane distillation technology for desalination purpose and also so as talked by earlier speakers also, we have about 70 to 75% Earth's surface covered by the water, but still more than 90% places we do not have safe drinking water. That is very well known fact. And more than 97% of water is saline, only 3% is fresh water, and out of that 3% fresh water, only 1% is having easy access. The rest is in glacier and ice caps, which is not having easy access for human being. So you can see the grim scenario of